I had to read the bio, and it was just a little more like third class thing, so I didn't. I'm not done that. I'm not Eight questions. It's a lot of you basically find conflict upwards down. That's and then that's one.
All right. Hello, everyone. How is everybody?
Tired.
Tired? Okay. Get some rest and manage your time efficiently. Yeah, it is not easy. I know you are multitasking, taking many courses, juggling from work, part-time job. It is not easy. Okay? I understand. Yeah. Okay, are there any questions before we start? Anything? Some students decide to, yes, questions? Thank you. The question is the term test 2 online or in person? It is in person. Term test 2 would be in person. We give you the paper, you write down the solution for the question on the paper. We collect the paper, we have TA mark your test, not the computer mark your test. Yes. Unfortunately, no. No resources, no formula sheet. Okay. Yes. When is the test? The test is March 17th at the same as the midterm one, 7 o'clock. I will double, give me 1 second, I need to double check. It is March 17th, Friday. I don't have time yet. I guess it is the same time as midterm test 1. Yes. Thank you. The coverage for test 2 is chapter 4 and chapter 5. 2 chapters in the textbook. Chapter 4 in the textbook, chapter 5 in the textbook. You have probably 6 questions, problem-solving questions, no multiple choice questions. You need to show all your work. Only provide the correct answer will result in 0. No mark will be given. You need to show your work. The mark is based on the steps and your final answer. Any other questions? Yes.
Is it based on week 6 and 7 or week 5 through 8?
The content is based on chapters. So chapter 4.1, 4.2, 4.4, 4.5, chapter 5. So week 5, we have chapter 4. Week 6, chapter 4. Week 7, chapter 4. Today is week 8. We have chapter 5. We'll also start chapter 6 today. Just chapter 4 and chapter 5. Any other questions? All right. Some students decide to join the class online. I have no objections because some students are sick, have family emergencies, cannot attend class in person. I understand. So it is the same link. Right now, I have few students online right now. If you have family emergencies, if you are sick, you can join the live class online. Okay, it is the same link I sent you last week. So each week, I use the same link here. This one here, live size. This link is available every Monday evening when I deliver the in-person class. Just let you know, okay, so that you can have choices. Any questions? Okay.
Are you going to be doing a review next week, like last time?
Next week, I will give you a little bit review for test 2, yes. Okay. Other questions? Outside class time, you can utilize the Mathematics Learning Center. Schedule is here. Every day, somebody is there. Here. Click this link on Bright Space. It is under Announcement. Bright Space Announcement. Scroll down. You have the link for Learning Center, Mathematics Learning Center. This Thursday, by 4:30, our written assignment 3 is due. Okay. I had my office hours before the lecture here. Tomorrow, Professor Huda is here. She is teaching daytime, MATH1p97. And we also have a teaching assistant here. Now Marshall, he also provides help for this course, all first year. We are first year course, okay? See, every day somebody is there to help you. If you have assignment questions, I strongly suggest visit in person. Of course, you can email me, but please expect 2 business days to have your email answered. And you have to be specific about the questions. Okay, so those are some logistics. Last questions? All right. Okay. Last, did the derivative of exponential functions. So today we'll do, just double check my lecture is recorded. It's shared. It is recorded. Okay. The disadvantage of attending, for example, this online class, I may not see your questions here, so just double check. How many questions will be the term test? How long? It will be 6 questions, 1 hour and 15 minutes, okay? Roughly, we will make announcement as the information is available. Okay, so last class we did a derivative for exponential function. Today, we'll do the derivative for logarithm function. Logarithm function. This is the function, the formula. The derivative of logarithm function equal to 1 over x. And how do we know this is true? We can write down, so first we write down fx equal to ln x and from here Remember, the logarithm function and the exponential function can exchange. So this is the logarithm function. How do I write down this logarithm function in exponential format? Okay, so let's practice basic format. So for example, if I have A equal to ln B, this ln means base E. It is actually the same as ln is log B logarithm base E. Base E, we write down ln. Okay, if you have this expression, means E raised to power A equal to B. So this is very important. How do you change from logarithm to exponential format? Sometimes the letters are changed. For example, if I write down y equal to log, logarithm base E, and then x, it is the same as E raised to power y equal to x. Okay, so based on this notation, if I give you fx equal to ln x, how do you write down this into exponential format? Based on the one I gave you the hint here. So from here, it should be E raised to power fx equal to x, right? And once you have E raised to power fx equal to x, both sides you take derivative. Left-hand side, when you take derivative, remember Ex derivative equal to Ex. But left-hand side is not Ex, it's Efx. So you have to use a chain rule for left-hand side. So it is Efx times derivative of Fx. That is left-hand side. Right-hand side, the derivative of x equal to 1. Okay. And then, what is E raised to power fx? It is x. See here, E raised to power fx is x. So you get x times f prime x equal to 1. So from here, f prime x equal to 1 over x. So we prove this one here. Remember what is f? Fx equal to ln x. So that means ln x derivative equal to 1 over x. Fx equal to ln x. Questions? Okay. Now let's find the derivative. This one, fx equal to x times ln x, we need to use product rule. Okay, so just remind f times g derivative equal to f g prime plus g f prime. We'll use this product rule. In question A, f equal to x, g equal to ln x. So in this one, f equal to x, g is ln x. Use the product rule. Okay. So solution for A, derivative of x equal to x ln x derivative plus ln x derivative, directly use the product rule, equal to x times ln x. See, ln x equal to 1 over x. 1 over x plus ln x. Derivative of x equal to 1 times 1. So the final result, x times 1 over x is 1 plus ln x. This is final result. Any questions? So this is B. This is A. For B, we need to use the quotient rule. So quotient rule said f over g derivative equal to g squared. So this is the quotient rule. So apply this one to B. So the derivative of B equal to square on the bottom and then ln x derivative minus ln x times x derivative. Directly use quotient rule for B. Copy down the bottom. On the top, ln x derivative 1 over x. X derivative is 1. So the final result is 1 minus ln x over x squared. Questions? Okay. Next is the chain rule for logarithm function. If you take derivative of ln fx, it is fx, it is the derivative of f over fx. So it is just f prime over f. And how do we prove this? This is the procedure. Okay. You let ln fx equal to gx. If you have ln fx equal to gx, this is logarithm format. How do you change to exponential format? So it is e raised to power gx equal to fx. So for example, if you have ln a equal to b, you are going to have a equal to e raised to power b based on this. You have this. Okay. And then both sides you take derivative d, both sides you take derivative. Left-hand side df, right-hand side you use the exponential derivative. And the chain rule from last week. So last week we did, if you have e raised to power gx and you take derivative, it is just e gx then times derivative of t from last week. And from here, both sides you divide it by e raised to power gx. Left-hand side divided by e raised to power gx. Right-hand side divided by e raised to power gx. Okay, and the right-hand side you have g prime x. Left-hand side you have f prime x over e raised to power gx. Here, e raised to power gx, it is just f. So we proved this one here. We proved. Questions? Okay, let's take a look at the example. Found the derivative of fx equal to ln x squared plus 1. And this one, it is we need to use the chain rule because this is ln x squared plus 1. If it is just ln x, we know the derivative is 1 over x. But since this is actually ln fx, take derivative, so it is fx on the bottom, derivative of f prime x. We just proved this. And here we have fx equal to x squared plus 1 is our fx. Okay, so you can say let fx equal to x squared plus 1. Maybe we already have fx. Maybe I will use another letter, gx. Gx equal to x squared plus 1. We just proved ln gx derivative equal to g derivative over g. We just proved this, just use different letter. Okay. So fx equal to ln gx. Both sides you take derivative. Left-hand side is just derivative of f. Right-hand side use this. Right-hand side it is gx, g prime x. Okay. Continue. Gx is x squared plus 1. G prime x is x squared plus 1. Derivative. So the final answer 2x over x squared plus 1. Questions? Okay, next question. Differentiate y equal to, use logarithmic differentiation. So for this one, of course, you can expand this. So for example, x equal to x squared plus x times x squared plus 1, you expand, equal to x4 plus x squared plus x3 plus x. You expand the original expression, then you use x raised to power n derivative equal to n x raised to power n minus 1. So derivative of y equal to 4x squared cubed 2x plus 3x squared plus 1. You get the answer. Okay, but the question asks you to use logarithmic differentiation. So you cannot do this method. If there is no requirement, you can use this expansion of original expression. Okay. Let me double check just on this side plus x. Yeah, okay. So now let's use logarithmic differentiation. So you are given a original function. Take logarithm, natural logarithm on both sides. Left-hand side, you have ln y. Okay. Right-hand side, there is a typo. I'm very sorry. Left-hand side, ln is missing. So the logarithm function is missing here. So should have ln right-hand side. Okay. I will rewrite it. So ln y left-hand side equal to ln x plus 1. So should be this one. And then recall if you have ln x times y equal to ln x plus ln y. This is the property of logarithm function. Okay, so keep on going. Left-hand side, you have ln y. Right-hand side, you should have ln x plus ln x plus 1 plus ln x squared plus 1. And now, both sides, you take differentiation. Left-hand side, you have 1 over y, then y prime. This is left-hand side. The reason is ln x derivative equal to 1 over x. But since y has x, y is function of x, so you need to use the chain rule on left-hand side. Right-hand side, take derivative with respect to x. You get 1 over x, 1 over x plus 1, 1 over x squared plus 1. The last item, you have to use the chain rule. Take derivative of x squared so that it becomes 2x. You have to take derivative for x squared plus 1. For last item on right-hand side. Yes. Correct. You have to take derivative of x squared plus 1. Derivative of x squared plus 1 is 2x. Thank you. So derivative of x squared plus 1 is 2x. And after that, our objective is to solve for this y prime. Okay? So both sides you times y, you get y prime equal to y times keep on going. What is y? Y equal to this one here. Plug in y to here. Okay, so you get the derivative. Any questions of y? Shall we move on? Okay. We already did that. So next, we finished session 5 of chapter 5. Next, session 6 of chapter 5, exponential functions as mathematical models. First, we talk about exponential growth. Remember the exponential function f(x) equal to b raised to power x is increasing when b greater than 1. A particular case of bx is ex. E is this number. That is natural number e. Okay, of course, this number greater than 1. Let's look at the exponential growth. Usually, we have this format. Qt equal to Q0 times E raised to power Kt. Q0 and K are positive constant. When T equal to 0, when t equal to 0, Qt becomes Q0 equal to Q0 times, just plug t with 0, K times 0 equal to Q0 times E raised to power 0. Okay, E raised to power 0 is 1, so it is just Q0. Q0 equal to Q0. And the graph for this function is like this. And this function intersects with Q at Q0. So this point is Q0. It is a rapidly increased. Okay, next, let's figure out what is the derivative of Qt. Remember what is Qt? Qt equal to Q0 E raised to power Kt. Both sides you take derivative. So left hand side you got this one. Right hand side take derivative. Q0 is constant. You can put the constant in front of the derivative. So it is just take derivative of E raised to power Kt. Okay. And then, what is the derivative of E raised to power Kt? So it is equal to E Kt. Then Kt take derivative, chain rule. Kt derivative, it is just the K. Usually we put the constant in front of a function, so k times e raised to power kt. Okay, so this part you copy down q0. So derivative of e kt equal to k times e kt. And if you take a look at this part, it is just qt. So the final result, the derivative of q equal to k times qt. Questions? This one, so if you have qt equal to q0 e raised to power negative kt, k is the positive constant. We call this function, this k constant is decay constant. And this graphical will be looks like this. It is decreasing. Questions so far? By the same approach, we can take the derivative of qt here. Remember what is qt? This one. If both sides you take derivative, so left-hand side and right-hand side derivative. Both left-hand side, right-hand side take derivative. So copy down left-hand side. The derivative of e raised to power is e kt times derivative of negative kt. Take derivative. So negative kt derivative equal to negative k times e equal to negative k times q0 times e negative kt. So remember what is this item? This is qt here, see? Okay, so equal to negative k times qt. What equal to negative k times qt? Q prime equal to negative k times qt. So this, I explained this slide, okay. The radioactive substances decay exponentially. For example, the amount of radium present at time t obeys the law qt equal to q0 e negative kt. q0 and k. q0 is the initial amount, k is the positive constant. And what is the half-life of a radioactive substance? It is the time required for a given amount to be reduced by 1/2. So that is half-life. If we know the half-life is 1600 years, and suppose there are 200 milligrams initially, found the amount left after t years, and what is the amount left after 800 years? That is the question. So let's So this is the question here. So how do we solve this question? First, we write down the general format. This is the general format. Qt equal to Q0 e raised to negative kt. Okay. And then we use the initial value. Initial value is 200. That means Q0 equal to 200. Okay, so that this expression, this one becomes Qt equal to 200 times e raised to power negative kt. And now, based on this one, the half-life is 1600 years. Okay, so if initially you have 200, what is half-life? What is the half of this 200? Initially, you have 200. What is half of 200? Anyone? Yeah, 100. Thank you. Initially, you have 200. Half is 100. And when this 100 happened, it is 1600 years. When t equal to 1600 years, q equal to 100. Okay, so how do we translate this into mathematical model? So when t equal to 1600, q equal to 100, you write down this. Q equal to 100 when t equal to 1600. So this is mathematical model. 100 equal to 200 times e raised to power negative k times 1600. And once you have this one, you have one equation, one unknown. Theoretically, you can solve for k. Okay. So how do we solve for k? Both sides divided by 200. Both sides divided by 200. You get this negative 1600 k. Okay. So left-hand side, you have 1 over 2. E raised to power negative equal to 1 over e raised to power positive. Any questions? And now you use cross multiplication. So for example, A over B equal to C over D. Cross multiplication, you get AD equal to BC. Cross multiplication. So from here, I get E raised to power 1600k equal to 2. Cross multiplication. Very useful mathematical property. So after that, I want to solve for k. So from here, I change to logarithm function. So 1600k equal to ln 2. Okay. So now I get k equal to ln 2 over 1600. That is k. But how do I know exact number for ln 2? is cell. So in Excel, you're typing ln. ln means long, logarithm based on e. I need ln 2. And then divided by 1600. So this is the answer, 0.000433. So this is the Excel formula. So I get this number, K. So this is K equal to any questions how to solve for constant K? So now once I found K, I found this answer. The question asks you found amount left after t years. The answer is Qt equal to 200 e raised to power negative 0.000433 t. This is the amount left after t years. Next question, what is the amount left after 800 years? So plug in t. Q800, t equal to 800. It is equal to 200 times e raised to power negative 0.000433 times 800. And how do I know this number? Excel. In Excel, you need to use exp function. exp, it is the e. Try to increase the so what I want to calculate 200 times e. In Excel, it is exp. Okay, natural number, the exponent function exp. So exp negative 0.000433 times 800. I need to calculate this. And it is 141.44 or 45. So this number equal to 141.44. Okay, so I solved for these two questions. Found the amount left after t years. What is the amount left after 800 years? Any questions? Okay, shall we take a 10-minute break? Come back at 7 o'clock. We continue. So break time. Yes.
Could you explain on slide 5? I got lost after this step here.
Oh, sure, no problem.
Wait, what did I don't know if I copied it down wrong.
Okay. Can you remind me the slide number?
5. Yeah.
Slide 5? Yeah.
Yeah. So how did that y become an x?
Okay. Original left-hand side is ln y.
Yeah.
Take derivative of ln y, it is 1 over y times y derivative, right? And then both sides times y here and y here. You have y cancelled. You just have y prime on the left-hand side. So right-hand side, you have y times this bracket.
Right.
So what is y? Y is this. This is y. So you plug in y with this. Copy down this bracket here.
Okay. So
Okay.
this y is actually becoming this.
Exactly.
And then you keep that bracket the same.
Exactly.
Okay. That makes sense.
Okay.
Okay. And then is that the final answer?
Yeah.
Okay.
Okay.
Thank you.
You're welcome, Cameron. Hello.
Sorry, I missed last lecture. When's the term test 2?
You missed the last lecture.
When is the
When
second
is
term
the
test?
test 2? Thank you for asking. It is March 17th. I will show you.
And is there like a, oh, it's in the course outline?
Yeah, the course outline method TBA. That's why we announced in class. So I will show. I mentioned in class somewhere here. Oh, here. Friday, March 17.
Okay.
Okay. And if you miss last class, you go to I recorded the lecture. You can catch up.
Okay.
You
and it's in person or online as well, like the
last class.
No, the term test.
Oh, the term test in person.
In person.
Because we are in person class. Okay.
Okay, I'm asking because the last one was online. So
yeah, I know.
okay, it's
yeah.
in person.
Okay. Yeah.
Yes, religious issue, like when the term test is on the 17th, right? We usually have like a religious event before Ramadan, so that's why I was gonna ask, when am I supposed to do for register office? Or
Go to this person. When you go to Web Assign, you see instructor Mark Willoughby.
yeah,
Email him. His email is also, I will
it's
show
on the
you,
course syllabus, right?
is also on the course outline. So he is the course coordinator.
Is there any way like I could switch it online this semester?
I don't think so. Again, double check with Mark Willoughby.
Because what's one of my friends said, if you have like an event, he's like you should switch to online because the online exam probably is on in person too, right? The final exam, right?
You are right. We have 3 different sections.
Right.
Professor Mark Willoughby is responsible for online section. His test 1 online, test 2 online, final exam
Because
online.
what's it called? Final online is the final date. When because I looked at the date, right?
It is
like,
April the 20th.
yeah, that's like the final day we fast. So you usually have like a big feast with the family. So that's why I couldn't make it.
So again, email Professor Mark Willoughby. That is the email address.
Okay.
Okay?
I'm trying to figure out.
Yeah, okay.
Thanks.
Yeah, you're welcome. Hello.
Why is ln y not equal to just 1 over y?
Good
1 over
question.
y times
Yeah,
1 times.
good question. Usually ln x equal to 1 over x.
Yeah.
That's it. But this time ln y usually is a function of x.
So you use
So
just
y has x inside. If you ln x, x is x.
Yeah.
If you learn y, you must use 1 over y times derivative of y, chain rule.
Okay.
Chain rule.
That's fine. Thank you.
You're welcome. Hello.
I was just wondering with this part right here, I think I get how we got here, but like, does this like if you're equal, like that a third?
Yeah, if you make a simplification, yeah, they should equal. They must equal.
But I got,
They must equal. You can take an exercise. They must equal. Good question, observation.
I was gonna see
How to equal? So you figure out this one. I can prove to you. Come over here. Good observation. So, okay, I will prove you from here. I will get from here. I will prove you the same as we get here. Okay, okay, now I will prove to you. Okay, so first I will simplify this guy. Okay, so I will do this 1 over x plus 1 plus 2x over x squared plus 1. I will do this. Then I multiply this. Okay?
All right.
Okay. So what I do this equal to x times x plus y, x squared plus 1. Then this one, I need to times this 2. So x plus 1 times x squared. This guy, I need to times this 2. So x times x squared plus 2. This guy, I need to times this 2. So it is x times x plus 1. Are you comfortable with this from here to here?
Oh yeah, I get it. 'Cause you have to make the bottoms equal.
Come on. Yeah. Okay, good. And now, so bottom is this one. We simplify the top. Okay. So actually, we already proved. Okay, this is bottom. This bottom cancelled out with this one here.
Oh, I get it. And then you just multiply all these.
Yeah, you just simplify this, you will get the one I showed you before.
Okay, I get it. Thank
Okay,
you.
thank you. Hello.
It was actually that example that I don't understand. How you went from the beginning to here. Do you mind going through it?
Oh, sure. So I will ignore all, I will start from scratch, okay? So we have y, but I need to copy down the question. X plus 1. Okay, so this is an equation. Mathematically, both sides I take ln. It is still equation, right? Ln. Now, both left-hand side, right-hand side, I take derivative. So now, left-hand side, when I have ln x derivative, I know it is 1 over x. But this is ln y has x. So, ln y derivative 1 over y, chain rule, take derivative of y. This is left-hand side.
Okay.
And the right-hand side, we use this rule. Ln x times y times z equal to ln x plus ln y plus ln z.
Okay.
Okay, this is the rule. So this 3 equal to ln x plus ln x plus y plus ln x squared plus 1. This guy take derivative. This is right-hand side. And then copy down left-hand side. Right-hand side, ln x derivative is 1 over x. Ln x plus 1 derivative, x plus 1, then take x plus 1 derivative, chain rule. Because it is not ln x, it is ln x plus 1.
That part I don't understand.
Okay. it is ln x, what is the derivative, really?
It's just 1 divided by x.
Yeah. And if it is ln f, okay, if it is ln x squared derivative, you cannot say this is wrong because this is a function. You have to take derivative of this one. So if it is ln x squared derivative, it is 1 over x squared, then take derivative of this function.
Oh, the chain rule?
The chain rule, yes.
Oh, so you up there, so you put that on top.
Exactly. Okay. So here you have to take derivative of this guy.
Okay.
Now this one, you tell me what is derivative of ln x squared plus 1?
It would be x squared plus 1, the derivative,
Perfect.
and then divided by
Perfect. You
x
got
squared
it.
plus 1.
You got it.
Okay.
Okay. And now keep left hand side, right hand side. On the top derivative is what? Just 1, right? This derivative 2x, right? Right? And then move this y to right hand side, becomes here, times this guy here.
Oh, so you just multiplied y?
Yeah,
Okay.
multiply y both sides. So you have y prime equal to this, y times this. So what is y? Plug in y into here, you get my final answer here.
Wait, you plugged in what y?
So this is y times this bracket, right? And what is y? Y is equal to x plus 1, x squared plus 1. That is y. Copy down the bracket. Yeah, from the beginning.
Oh, okay. And then you just replace this y.
Yeah.
Oh, okay.
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 Yeah.
Thank you.
You're welcome, Riley. Hello.
I just had this query that in the assignment from page 265 and exercise 23.
This is 366.
Okay.
Thank you for asking. 366. Yeah. Hello.
Just a quick question. In the derivative for q, t, and q, 0, e to the negative t, how did you, kt, I understand that e to the negative kt prime is the base e to the negative, like doing the chain rule.
Yeah,
Okay?
yeah.
How did you get negative kt prime to just negative k? Like, where did t go?
Okay, good question. If I have a 3x, take derivative, what is this?
It's 3.
3. If I have negative 4x, take derivative, what is this?
Negative 4.
Negative 4. Now, if I have negative kx, take derivative, what is this?
Oh, it's just, it's k, negative k. So
Yeah.
t in that sense, because it's a qt.
Yeah,
Right, of
x
course, yeah.
plugging
Yeah,
x in t.
Yeah, okay,
Yeah.
definitely. Thank you very much.
Thank you for asking. All right, welcome back from break. Hope you have had a nice break. Are there any questions? Anything? Okay, before break, we did exponential functions decay. So where we are? So we are here. We solved for this. We did this. Finished. We finished this one. Did we finish? No. Yes, we finished this one. We got this number. Okay, so before break, we finished this one. Okay, we answered the questions. 800 years later, how much left? Now, we'll go over the learning curves. Learning curves. And what is the learning curves? This function is we call learning curves. We have C, A, K. They are positive constants. If you have a function looks like this, it is a learning curve. And what is the function looks like? So first, we observe that if t equal to 0, so what is Q0? So just plug in t equal to 0, k times 0. This is the original function. E raised to power 0. E raised to power 0 equal to 1. So it is a Q0 equal to C minus A. Okay. So what does it mean? Q0 equal to C minus A means y-intercept is C minus A. Okay. And now there is a typo. Sorry for the typo. This one is a Q prime, not Q. So Q prime equal to K times AE negative KT. Why? Because if Q equal to C minus A times E raised to power. So what is Q prime? What is the derivative of Q? So equal to the derivative of constant C is 0. Okay. Then take derivative of negative KT E. Take this derivative. And then it is equal to negative A. What is derivative of E? Raised to power negative KT. It is E negative KT. And then chain rule negative KT derivative. Okay. Keep on going. So it is a negative A times E negative KT. What is derivative of negative KT? It is just negative K. We have negative. The result would be positive AKE. Negative KT. Okay, so this is there's a title here. This is how we comes up with Q prime equal to KAE negative T. So Q prime equal to this one. Okay, and now if K and A are both positive, if K is greater 0, A is greater than 0, Q prime must be greater than 0. And if the first derivative is equal to 0, it must be increasing Qt. If the first derivative is positive, then the function must be increasing. Okay. What we are doing here, we are trying to sketch the graph of Q. How do we sketch the graph of Q? First, we found y-intercept. What is the y-intercept? It is just C minus A. Next, we take derivative of Q, and we found the derivative greater than 0. So we know this function is increasing. Okay. And then we take the limit when t goes to infinity. What would Q looks like? So we take limit C minus A e raised to power kt when t goes to infinity. The constant, it is just a constant. And what would be this derivative? When A e raised to power negative kt, when t goes to infinity, this is the same as A times limit 1 over e raised to power kt. When t goes to infinity, this number on the bottom is a very big number. Okay. If you have a very big number on the bottom, on the top is 1, the result is 0. If you have a very big number on the bottom, the limit is 0. Okay. So we know this limit is 0. So it is C minus 0 equal to C. Okay. And now we can sketch the graph of QT. So how? So this is T, this is Q. How do I sketch the graph of this one? First, y-intercept is C minus A. This point is y-intercept. It is C minus A. Next, QT derivative greater than 0, it is increasing. So the graph is here, increasing. Okay. And then this graph, this function, when t goes to infinity, approach to, it is approach to C. So this graph, increasing, but it is approach to a constant C. So this point is C. See, this is C. When t goes to infinity, this approach to C. So this is the graph of Q. Okay. First, find the intercept, then identify it is increasing. After that, find the limit when t goes to infinity. Okay. And this is the learning curve. So at the beginning, it is increased a lot, but after a certain point, it is saturated. It does not increasing. It is just a constant C. See, it is flat. Okay. So this is the learning curve. Okay. Take example of learning calculus, learning this course. So it is always take a lot of time after you study a new chapter. It takes you a lot of time to review class notes, go over class example, look at the textbook example, okay, do the questions from the textbook, from web assign, take a lot of time, okay? But after, you spend lots of energy, your performance is like this, actually. Okay, so the beginning of everything, it is a lot of effort, time. Okay, so we know this is the sketch of the graph. See, this point is C. This intercept C minus A, it is increasing. When xt goes to infinity, it goes to C. Okay. All right. You can read by yourself. Now let's take a look at example. Example. Optical produces 35 single-lens reflex camera. Eastman's training department determines that after completing the basic training program, a new, previously inexperienced employee will be able to assembling this amount of camera. T is T months. T, the unit is months. Okay. Question A, how many models can new employee assemble after basic training? That is the question. And how do we answer this question? Given a function Q, this is how many cameras produced per day. Question A, how many cameras a new employee can produce after basic training? Anyone have idea how to solve this one? So this is asked you when t equal to 0. When t equal to 0, what is Q? That is the question. So you just plug in t equal to 0. You got 50 minus 30 e raised to power -5 times 0. So 50 minus 30 times e raised to power 0 equal to 50 minus 30 equal to 20. That is 8. 20 cameras a new employee can produce. Questions? Question B. How many cameras can employee with 1 month's experience? How many cameras can employee produce with 2 months experience? How many cameras can employee produce with 6 months of experience? So question B asks you, when t equal to 1, what is Q? When t equal to 2, what is Q? When t equal to 6, what is Q? That is question B. So go back to Q, function Q. Okay. I will erase this. So question B asks you, when t equal to 1, what is Q? Okay. So when t equal to 1, Q1 equal to 50 minus 30 e negative 0.5 times 1. 50 minus 30 e negative 0.5. So how do I know how to calculate this number? Excel. In Excel, E is EXP, exponential function. So this is the formula in Excel. 50 minus 30 times EXP, negative 0.5. So you get this number. And the next question, how many cameras an employee with 2 months experience? So when t equal to 2, what is Q? So Q2 equal to 50 minus 30 e negative 0.5 times 2 equal to 50 minus 30 times e raised to power negative 1. And what is this number? So I just copy down the formula. So I will just change negative 0.5 to negative 1 in Excel here. So this is the answer. 38.96. Okay, last question. When t equal to 6, how many cameras with 6 months experience? So Q6 negative 0.5 times 6 negative 3. $48.5. Questions? Question C. How many cameras can average experienced employee assemble per day? So remember what is the graph of the learning curve? So experienced. So these are the experienced here. So the experienced guys are here. Those are learning new employee in the training. They are in the training. Those are experienced. So the answer is C. Did you see that? C. Okay, what is C? Remember this function? Here, the first number is the average for experienced. Okay. So the answer for question C. So it is just this number here, 50. 50 is the experienced. And mathematically speaking, question C asks you when t goes to infinity, what is Q? That is the question. So you take the limit when t goes to 0, the original function, the limit equal to 50. We proved this, right? We did that. Okay, questions? All right. So we did all of this. We use Excel. So far we did the learning curve. Next, another important function is the logistics growth. If a function like this, we call it the logistics growth function, also called logistics function. Okay. So what is this logistic function looks like? It looks like this. Also similar to the learning curve. Okay. This is the logistic function. Okay, let's take a look at example for logistic function. The flu, the number of soldiers at Fort McAllister who contracted flu after T days during a flu epidemic is approximately by exponential model. This model we call logistic function. If 40 soldiers contracted the flu by day 7, found how many soldiers contracted the flu by day 15. T represents the day, T days, T represents the day, Q represents how many soldiers contracted flu. Okay, how do we solve this question? So if 40 soldiers contracted flu by day 7, from this statement, it is implies when T equal to 7, Q equal to 40. That is the meaning of this statement. So we plug in T into the equation, solve for the constant K. So Q equal to 40 when T equal to 7. T equal to 7 when Q equal to 40. Okay, and now we have format like if you have A equal to B over C, naturally A times C equal to B. Okay, so we use this 40 times this one, 40 times 1 plus E raised to negative 4K equal to 5,000. Okay, and then we move this 40 to the right hand side, becomes divided by 40. Move 40 to right hand side, becomes divided by 40. And the reason is I want to simplify this. So 0, 0 cancelled out. 500 divided by 4 equal to 125. Okay, and then move, so I'll rewrite it, 1 plus E raised to power negative 4K equal to 125. And move this one to right hand side, you have 124. I move the left hand side one to right hand side, you have 124. And then you have E raised to negative 7K. I will E raised to negative, I will write down positive 7K here, equal to 124. And then E raised to positive 7K equal to divided by 124. So I need to know this number equal to what? This number equal to 10.072. .072. 10.07258. 10.7258. Okay, this is this number. And then I want to solve for k. So 7k equal to ln 10.07258. 7k equal to ln. And then k equal to ln divided by 7. That is k. So now I need to use Excel to figure out this number. But to ln this number divided by 7. I get k equal to 0.3299. Any questions? I solved for k 0.3299. I'll go back to original question. I just based on 40 soldiers contracted by day 7. I solved for k. Now, once I get this k, I can answer next question. How many contracted by day 15? Means what is, so when t equal to 15, what is Q15? That is the question. When t equal to 15, what is Q15? Okay, so Q15, you just plug in the formula. So Q15 equal to, plug in this formula, plug t equal to 15. And we already solved for k equal to 0.3299. So e raised to power k 0.3299 times t. T is 15. We need to figure out what is this number. So again, Excel. So this is the number. $507.07. Any questions? We solved for example 6 using logistic function. Okay, so we solved all of this. We finished chapter 5. So in summary, chapter 5 talk about exponential function, logarithm function, derivative of exponential function, derivative of logarithm function, compound interest, also in chapter 5. And finally, the logistic functions, okay, decay functions, those are the chapter 5. Any questions before we move on chapter 6? Chapter 6 is antiderivative. So what is antiderivative? I will use example. So if you can find a function capital Fx, and this function derivative is another function, so okay, there are two functions. One is capital letter Fx, the other function is small letter fx. What is the relationship between capital letter Fx and small letter fx in this example? The relationship is, if you take derivative of the capital letter F, you get the small letter Fx. Did you see that? If this is the case, we call capital F is the antiderivative of small f. Okay. I'll give you another example. If you take derivative of this function, what would you get? Take derivative of this, you'll get 3x squared plus 2, right? And we call this function is the antiderivative of this function. Any questions? Okay, still another example. If you take derivative of this, what do you get? You get 5x4, 12x3. Because of this, you call this function is antiderivative of this function. So this we use capital letter F, and this we use small letter f. Hope you understand what is antiderivative. Okay. Okay. But take example of this one. Okay. If I say take derivative of this function, what is the derivative? The result is this one, right? That's why this is antiderivative of this function. So can you say you have an unlimited number of antiderivative function? Because I can give you another example. This function, if you take derivative, it is still the same result. Did you see there are many antiderivative functions? Did you see that? The difference between many derivative functions is by a constant. If you use graph, you have many antiderivative functions. The difference is only differed by a constant. There are many antiderivative functions. Okay. Okay, so once we understand that, we introduce a new concept, indefinite integral. What we try to do, we try to find all antiderivatives of function. That process is antidifferentiation or integration. Okay. How do we find antiderivatives? We use integration. Mathematically, this sign is integral sign. Okay, this one here. This. Okay. Small letter f, if you use integration, you can get antiderivative. Capital F is antiderivative function. There are many antiderivative functions. We use plus like constant c. For example, we know if you have capital F equal to x squared plus 1, what is small letter f? It is just 2x, right? So we say 2x dx equal to x squared plus c. And this one here establishes the relationship between small fx and capital Fx. This is one format of relationship between capital Fx and small fx. Another relationship is this. By definition, if you take derivative of capital F, you get small f. This also shows the relationship between fx and capital F and small f. Two formats. This is format 1, this is another format, showing what? The relationship between capital F and small f. Capital F has a name, antiderivative of small letter f. There are some basic rules. If you take the constant, k is a constant, integral of constant, it is just kx plus c. Why? Because if you take derivative of kx, what do you get? You get k. Okay, you get k. Okay, now let's take a look at example. Find the integral 2 times dx. It is asked you which function the derivative is 2. Can you think a function the derivative is 2? Which one? Which function when you take derivative it is 2? Excellent. That is the meaning of this integral. So it is 2x. Did I miss anything? 2x is correct, but not perfect. Excellent, plus c. Because there are many, remember there are many antiderivative functions. There are many. Okay. Question B. Which function when you take derivative equal to chi squared? Yes. Excellent, pi squared x plus c. Okay. Next question, I will add a new question here. Question C. This need a little bit thinking, okay? X dx. Which function, when you take derivative, the result is x? Yes. X squared, 4x squared, x squared over 4. Oh, thank you, sorry. X squared over 2, perfect, plus c. Don't forget plus c, because we have many antiderivative functions. That's correct. If you take derivative of x squared over 2, what do you get? You get x. Okay? So generally speaking, if you xn dx, which function the derivative is xn, the result is this function. X raised to power n plus 1, there is a constant 1 over n plus 1 plus c. If you take derivative of right-hand side, you will get the result of derivative of right-hand side equal to x raised to power n. Okay, so this is this formula here. Okay, 2 more questions. All these ABC questions use this rule. So I'm going to write down that rule on the side. Xn derivative equal to 1 over n plus 1, x raised to power n plus 1. Do not forget plus constant c. So let's do question A. N equal to 3, so it is equal to 1 over 4 times x raised to power 4. Okay. And the question B, n equal to 3 over 2, so equal to 1 over 1 plus 3 over 2 times x raised to power 3 over 2 plus 1 plus c. So equal to 1 over 5 over 2 times x raised to power 5 over 2 plus c equal to 2 over 5 x raised to power 5 over 2 plus c. That is B. Questions? Question C. You need to rewrite question C equal to x raised to power negative 3 over 2. Negative 3 over 2, so that n is negative 3 over 2. And then apply the formula. So equal to 1 over n plus 1, negative 3 over 2 plus 1, x raised to negative 3 over 2 plus 1 plus c. So equal to 1 over, 1 is 2 over 2, so negative 1 over 2, x raised to power negative 1 over 2 plus c equal to negative 2x negative, or you can simplify negative 2 over square root of x plus c. there is an easy way for in integral, you check the integral. How do you know the result, this result is correct for question C? How do you know? Anyone? How do I know negative 2 over x plus c? That is the correct answer for question C. How do you know? Yes. Thank you. If you take derivative of the result, it must be equal to this one. If it is not, your answer is wrong. If the derivative of the result equal to original function, you are correct. So there is a way to check the integral if you did it correct or not correct. Okay. All right, shall we take a 10 minutes break? Come back at 8 o'clock, we continue.
Another question.
Oh, sure, allow your questions.
So we finished the assignment for this week, but this one, we're not sure how far to simplify it or expand it using the log rules. So we got to this answer, and then we further simplified it to this. But I'm wondering if I should like simplify these two together since they have the same base instead.
Absolutely.
Okay.
Yeah.
So this would be incorrect. I should simplify this.
So this one you should combine, collect like terms.
Okay. I'll do that.
Yeah.
So then it would be like 1/2 1x.
So this would be 2 minus 1 over 2. It should be 3 over 2 ln x.
Oh, I see. And then should I leave it as that or?
Yeah, 3 over 2 ln x.
And then can I further like simplify that or leave it?
No, just
No.
leave it. Yeah.
Okay. Should I do like 3 ln x over 2 or just leave it how it is?
It should be just 3 over 2 ln x.
Okay, sounds good. Thank you.
Yeah.
How are you?
Good. So this one coming from original function. So this Q represents how many days. This Q represents how many people get flu. Okay. Original function you have 1. So it is said after 7 days you have 40 people got flu. So 40 on this side, T is 7. And then use this 40 times the whole bottom thing here. Remember, if you come here, can you remind me which slide? Maybe I can just use a blank space here.
Yeah, I don't remember which slide.
Oh, no worries. Yeah. Mathematically, if you have A equal to B over C, naturally you got AC equal to B. That is that steps. Okay. So you have 40. 40 is A. Something on top. This is B. Something on bottom. This is C. So use 40 times this guy equal to this. Okay. 40 times this guy equal to something on the top. You get this one. Right? This one is coming from here. You have 1 plus. And then 40 move to right hand side. You need to both divided by 40. This is not 4, sorry. Oh, it is, yeah, 0, 0, that's correct. 500 divided by 4, 125. Minus 1 becomes 124. So 500 divided by 4 equal to 125. But there is 1 here, so it is 124.
Okay. Oh, thank you.
You're welcome. Thanks for
Sometimes
asking.
I just don't see that.
I got it. Just add the
All right. Hello. Welcome back from break. Any questions? Okay, before the break, we did some example about indefinite integrals. After you found the integrals, you have a way to check is your answer correct or not. So take example. You found the integral of x cubed equal to 1/4 x4. How do you know this is correct or not? You take derivative of your result. So the derivative of this one equal to this one, equal to x cubed. Match original function. So you are correct. Okay, this is the way to check the integrals. Some basic integral rule. If you have constant, you can move the constant outside the integral side. For example, if you have 5x squared dx, it is equal to 5 integral x squared dx. Move constant outside the integral. Okay, now let's do question A. First, we can move these two outside the integral. Next, we use the rule xn dx equal to 1/n plus 1 xn plus 1. We use this rule for t cubed. So it is equal to 3 or 1 n plus 1 or 1 plus n. Okay, so 3 plus 1 t raised to power n plus 1 4 plus c. So the final answer 4 t4. So 1/2 t4. Questions? So for question B, move -3 outside the integral side. So you have x raised to power -2. -2. So plug in this formula, n equal to -2. 1/2 plus 1, -2 plus 1. So equal to -3, -1, x -1 equal to +3, x -1 equal to 3/x plus c. I strongly suggest when you go home, redo these questions. Redo this question. Okay. Another basic rule, if you have two functions add together, take integral separately, then add the result of integral. If you have two functions, do the minus. Take integral first, then do subtraction. Okay, take example of this one. Okay, so this is the same as take integral of individual functions and then found each individual integrals. So the first one is 5 plus 1 x6. The second one is 1 plus 3/2 x plus 1 minus 2, 1 minus 1/2 x plus 1 plus 6. Okay, and equal to 5 plus 1 is 6, so 1/2 x6. And this one is 5/2 and 5/2, so 5, 2. 2 times 4 is 8 x 5 over 2. And the next one, negative 4 x. Okay. Questions? And this rule said Ex integral equal to Ex plus C. So example 8. So this integral equal to 2Ex minus x3 dx and equal to take 2 out x3, it is 1 plus 3 x4. And Ex integral, it is just every time, it is just Ex minus 1 over 4. Do not forget plus C. Questions? Okay. So what is the x raised to power negative 1 integral? It is ln x absolute value. Let's do this one. So this one would be equal to 2x plus integral 3 over x dx plus 4 over x squared dx. And then 2 move out, x dx equal to 1 over 2 x squared. 3 moved out, 1 over x is ln x absolute value. Next, move 4 out, 1 over x squared is the same as x negative with negative 2. So with negative 2, 1 minus 2, x negative 2 plus 1. Do not forget the plus C, constant. So equal to x squared plus 3 ln x absolute value minus 4x minus 1 raised to power negative 1. This is the final result. Or you could write down 1 over x, this item here. Any questions? All right. So, differential equations. Okay, differential equations. Suppose you have a f derivative equal to 2x plus minus 1. How do you find this fx? You take integral of 2x minus 1, you can find for fx. Okay, you can find fx. So this is an example of differential equation. It is an equation that involves in derivative or differential of the unknown functions. All right, so remember when you did the antiderivative functions, you have many. Okay, same thing for the differential equations. You could have many functions. Let's take a look at the example here. Directly jump into the example here. Find the function f such that f derivative equal to 3x squared minus 4x plus 8. When x equal to 1, f equal to 9. This is this meaning. When x equal to 1, f equal to 9. Okay. So first, we found f. F is just integral of this function. This is f. Take integral, and the result of this integral is 3 times 1 plus 2, x raised to power 2 plus 1 minus 4 times this x is x1, so 1 plus 1 x2 plus 8x, do not forget plus c. Okay. So further simplify, 3 cancelled out, x cubed minus 2x squared plus 8x plus c. So this is fx. Just take integral, you found fx. Once you found this fx, use the initial condition here. When x equal to 1, f equal to 9, this is given. So left-hand side is 9, plug in x is 1, times 1, 8 times 1 plus c. Solve for c. So c equal to 2. Any questions? We got c equal to 2. So plug in c equal to 2 to this one, we found the final result. Okay, questions for differential function. Differential functions, equations. So last session for today, integration by substitution. So try to do this one, take example, integral. First, I will not use substitution, then I will use substitution. So without using substitution, do you agree this one equal to 2 integral 2x plus 4 raised to power 5 dx. I will write down, maybe I will directly introduce the substitution, maybe easier. So, okay, so the question asks you to find the definite integral. What you do, you let you do substitution, u equal to 2x plus 4. If u equal to 2x plus 4, both sides you take derivative d. So du equal to d 2x plus 4. I pause for a moment because this is the first time we see this expression. U equal to 2x plus 4. Both sides you take D. The reason is, I will tell you later. So right-hand side, you have 2dx. Constant can move in front of d. And the constant derivative is 0. 4 derivative is 0. So it is just this one. I try to go slow because this part is important. This part is the new phenomenon we just met. So especially this part. Okay. How do you get this part from this one here? You take derivative d on both sides. Take d on both sides. Okay. So far, so good. Any questions? And now this function, original function, I will rewrite it. I will move this 2 to here times 2dx. Do you agree? It is the same expression. I just move the position of the 2. The reason is I have 2 times dx here. You see? Wow, I got 2 dx here. Did you see that? So this one becomes 2 dx is just du. Did you see that? 2 times dx, 2 times dx equal to du. And then I said 2x plus 4 equal to u. So it is u raised to power 5. Original function becomes this one. I just want to pause for a moment to let you digest this transformation. Once I get this one, easy job, because we have this guy here equal to n plus 1 x n plus 1, or 1 plus n, and plus c. Did you see it? So what is u squared or u raised to power 5? 1 over 5 plus 1 u 5 plus 1 plus c. Okay, this is the side note. And this one, 1 over 6 u6 plus c. And then, do not forget, replace back u with x. What is u again? U equal to 2x plus 4. 2x plus 4 is u. You done. You get the final result. So that is the substitution, method of substitution. Any questions? Okay, so move on. Let's move on. I already did all of this. Okay, we did that. And how do you know? Okay, let me return back to here. I said this is final result. How do you know this is correct? How do you check? You take derivative of this to see if you can get this. Take derivative, the result must be this. It is proof you are correct. This as exercise. Go home, take derivative of this. Can you get this? Okay. Okay, So we did that. Again, when you go home, redo this substitution to see if you can come up with the correct answer. All right. So now questions, this example, another example. So do this. Use substitution. So I will start from here. Let u equal to x squared plus 3. If u equal to x squared plus 3, both sides you take d. Left hand side d, right hand side is d. Keep on going. Left hand side du, right hand side derivative of 2x or x squared is just 2x dx. Derivative of 3, 0. Constant derivative is 0. And now rewrite original function to raised to power 4 times 2x dx. I just make rearrangement, move 2x close to dx. And then, did you find out, see 2x dx here, 2x dx here. So I will replace 2x dx with du. At the same time, I will replace x squared plus 3 with u. So u raised to power 4, then du. Did you see this? Du is 2x dx. Initially, I make u equal to x squared plus 3. And now it becomes simple, okay? And we all know this. I will just speed up. This one is u raised to power 5 plus c. And then plug back to u. What is u? U equal to x squared plus 3. So this is the final answer for this integral. Final answer here. Again, make home, redo this substitution by yourself without looking at the solution. If you're stuck, look at solution. All right, so that's all for today's lecture. Thank you so much. We do have some time. If you do not have questions, feel free to go. Thank you so much for your participation. I know it is a long hour lecture. If you have questions, please stay. I will be happy to answer any questions. Take care. Good night. Thank you.
Excuse me?
Yes.
With that last example, you don't have to put the 2x that was in the beginning in the final product?
No, you can't. You can only put constant in front of the interval. You cannot put x in front of interval.
But I'm saying it had 2x in front of it at the beginning. That doesn't
Come
matter
over
anymore?
here, yeah. This question,
Yes.
this 2x,
Yes, that's 2x. That doesn't matter in the end. I don't need to put that back in, like for the final product.
no,
No.
because this is my final answer, u. Just plug u here. What is
Okay.
u? I already move this 2x here.
I see. Okay, thank you.
Thank you for asking. Hello.
When we are integrating two or more than two terms, like so in the end when we integrate, why the answer isn't like in 2c or plus 3c?
It should be have c.
No, not just like when we are using addition property like in integration, like when there are two terms, two different integrals, and when we when the answer comes up, like so we don't have 2c, we only had c.
Do you mean if you have c1 plus c2, we just write down c?
Yeah.
Because one constant plus another constant, it is a new constant. So we just simplify using c.
Okay, so we only write
You
c
can
as
still
one.
write down c1 plus c2, but by convention, people like to use just one c.
Okay.
Thank you for asking. Hello.
I was just wondering how would this one right here become that right there?
Okay, so I know that is not easy to answer or not. Yeah. So this part you are okay. Just take both sides d.
Yeah, just do the derivative of
Yeah,
both
yeah, yeah.
sides.
And hold from here to here.
Yeah, that's what I'm confused about. I don't know where the 2 came from.
Okay. If I ask you, this might be x squared, not 3.
Huh.
Yeah.
Oh, okay. I just accidentally wrote it wrong.
Okay,
Yeah,
that
I
is
get
x squared. So x squared derivative 2x.
it. Okay, I get it now.
Oh, okay.
I just wrote it down.
Yeah.
Thank you.
You're welcome. Hello.
Notation.
Oh, yeah.
When do you use like a capital F and a lowercase f?
Good question.
Because capital F, that was
Okay.
it was like
So
antiderivatives, right?
tell me what is this derivative? Tell me x squared derivative.
2x.
When you have this, we call capital F is x squared. We call small x is 2x. You understand?
Okay. So the derivative would be the lowercase.
Exactly.
Okay.
So remember this example will help you distinguish capital F, small f.
Yeah. Okay.
Okay. Thank you for asking. Hello.
Just to follow, for the last example, this is what we have integrated.
Yeah.
So with here, with substitution, you rearrange this equation to here.
Yeah.
So you just multiply 2x by the x.
Yes.
And then what you did now, you substitute because you found u equals to 2x dx. This is u.
Yeah, this is du.
So
This is du.
And this inside is u.
Yeah.
And you put it back together, and then for the final answer, then you replace u with here.
U is here.
With here.
Yeah.
Oh, okay. So that's what it was substitute.
Okay. Hello, Ryan.
I think something. Sorry, I missed. Would I be able to look at your slide?
Absolutely, yeah. Tell me your slide number.
I'm just trying to find it because it was here and then I lost it. It was the one right after break.
First break or second break?
The second break.
So roughly like 40
It's
over.
44.
Yeah, 40 something.
I just have to finish B.
Sure.
I wish I could have been a little more.
44 is this one?
Yeah, that one. Do you have like what you
Number 6.
like what you wrote
This
for?
one?
Yeah.
Maybe here. More.
Sure. Can I just take a picture of it? And then
Absolutely, yeah, absolutely.
Thank you.
You're welcome, Ryan.
Yeah, and then I'll copy that down. And then next week I'm gonna do the lecture online.
Yeah.
Do you record the lectures?
For sure, I will do the same thing as last week.
Okay.
And if you cannot attend online, I will post the lecture recordings.
Okay, perfect.
Yeah.
Thank you. Because I'm going to try. Like I'm going to go on it, but it's like if I don't learn as good online. Right?
You watch online recording.
Yeah.
I will send to the whole class.
Thank you.
Yeah,
Thanks.
thank you.
And then I emailed Mark right after I got off. But I was later that night when I was on the went to your office hours. So I emailed him and he messaged me. This is the email he sent back. I think it was just kind of like I just kind of said explaining like my, what I was doing, and then he just kind of sent back like what the syllabus says. So I don't think he's. So that's like I think he just took that right from the syllabus. So
So looks like he will not accommodate you. So
I guess so. I booked a flight home.
I know,
It's like I'm gonna try to fly home myself. Like
show him the ticket.
Okay.
The flight ticket. At the same time, CC the chip of the department.
Okay. Like so, do you think I should show him like plane ticket?
Absolutely, you need the proof, the evidence. Otherwise, every student will ask this after. You have to understand from his point.
Right. Because I asked him, like I explained my thing, and then he didn't really give me an answer, right?
I know. Supply the travel ticket. You already booked the ticket.
Yeah, just
before you know the.
Yeah.
Yeah.
So I'll try it. Yeah, I'll see. I booked the flight like to try to get home.
I know.
It's not super cheap.
Yeah.
I appreciate it. So I'm going to try to. I'm going to join the live one.
Yeah.
But so you will record it.
I will record it. Assume the technology is working well.
Okay. And then if not, you're going to send it to everyone?
I was going to send everyone for next week lecture.
Okay, thank you. Thanks, and then I'll rewatch it again. Just so I'm up to date. Thank you.
You're welcome.
Hello. Question. For this one, we got -4 x to the -1, but here got power of -2.
Can you remind me slide 49?
Yeah. I think we did it right, but I wanted to make sure.
Maybe sometimes the typo.
Yeah.
I'll double check. Thank you for bringing that up.
Yeah, no problem. But it makes sense why it's -1 because it would be -2 plus 1.
Yeah, for sure this is a typo.
Okay, that's okay.
Yeah.
And then what else was this? Oh, it's just the formula for long. Okay. And then what slide are we? 61.
Oh no. Some slides I didn't finish on purpose because I want to do it in class. This is correct because this is unfinished work. Still have integral.
Oh, so they haven't brought up.
Yeah, the result of the integral have to be continued. This one is to be continued.
Okay. And then for this stuff, how do you wait? Is this it? Yeah. The derivative of this, how do you get dx? Like, isn't the derivative of 2x plus 4 just 2x? Or 2,
I got your question, yeah. So, this is the derivative of 2x.
Yeah.
Your question is why it is d. So, the derivative of 2x is just 2.
So, why do we have dx?
Good question.
Is there like a mathematical reason?
So like d 2x plus 4. Okay. So forget this one. Let's say x squared take derivative. So this derivative is 2x.
Right.
Okay. And remember what is this guy here? This is dy over dx.
Right.
Okay, and y is x squared. Okay, so then if I see from here, if I delete this one, do you see dy dx equal to 2x? Then I move this dx to the right hand side. I got dy equal to 2x dx.
Okay.
And that's how you get
But
this?
yeah.
Exactly, yes.
Oh, because this is technically du over dx.
Yeah, it's similar.
Oh,
Okay, so then you're just, to get du, you have to bring the dx over to the
Yeah,
other
yeah.
side. Okay,
Yeah.
that makes sense. And then, where are we? What was I gonna ask? I forget now. I was talking to you about it. Oh, when you have like u to the power 4 times du, does du always just equal 1? Like you just do the rule for this?
If you have this, it is the same as if you have this. How do you understand this? You understand this.
Oh, so it's just the derivative of
It's
x
just
to the
different
power.
letter, yeah.
Okay.
The
So then,
derivative of x is always 1.
Yeah, and I can even write down
Okay.
maybe something z for dz. Same thing, different letters.
so if these two are the same, then that just means the derivative of that would just be 1.
Yeah,
Oh, okay.
yeah.
It's if they're different, and that's when you'd have to do like like you know how you have to do, like in terms of x.
So this is in terms of x, this is in terms of u, this is in terms of
Okay.
z. This may be y for dy in terms of y.
Right. Okay.
As long as they are consistent.
Then it would just be 1.
Yeah.
Constant. Okay, that makes more sense.
And when do we know when y has x?
Yeah, that's what I was trying to say.
When do you know y has x?
Like, would that be if this was like y to the power 4 dx? Then y would have x.
Usually you have to give the taking the context. Normally we say y has x. Normally.
Okay.
Okay, x is just x. Y has x normally.
So when we see y, we should always assume that it has x.
Not always.
Okay.
Read the question based on the context.
Okay. But if these are the same, then it's a constant.
So I can put t, dt. I can
Any
put
number.
any letter.
Or
And
Yeah.
that will just be 1.
Yeah.
Okay, that makes more sense.
Okay. And when you put d in something in front of anything, it just means the derivative of whatever that is.
Right.
Okay.
Sounds good. Okay.
Okay.
Thank
you very much.
Thank you for asking. Yeah.
Thank you.
I see it on the bus. Yeah, I didn't see it on.